This is section 2.6, and today we're going to talk a little bit more about doing some proofs, only these ones are going to talk about angles. So up until now you've really focused on segments and using the same types of steps for proofs. We're just going to do these today but with angles. So the first one we're going to look at is I'm given that measure of angle 1 and 2 equal 180, and then 62 is how much angle 1 is. We want to prove that angle 2 equals 118. I think most of you looked at that, you could figure that out because 180 minus the 62 would give you 118. We just want to construct it as kind of a proof so we can get a feel for what it's supposed to look like. So the first step is always your given. So I'm just going to fill that stuff in and with my reason given. So the second one, what I'm going to do is what you probably did in your head, which was kind of put the 62 right there. And that's called substitution. And so that's what you did, and then I'm assuming in your head you just subtracted off the 62 and ended up with 118. So our reason there is subtraction. So a very simple problem to do. If I gave you this picture and I said that this was 62, I think most of you could come up with 118. I'm just putting into words what actually happened. That's kind of what a proof is all about. Now let's do one that's a little bit more involved. So this one has given that angles 1 and 3 are equal, and you can see that because they put those little red arcs there. So the measure of angle 1, it actually should say, oh no, that's equal, my bad, equal to the measure of angle 3, and that's given. In the end, we're supposed to talk about angle EBA, so this whole angle, and we're supposed to talk about how it's equal to angle DBC. DBC is right there, so it's talking about this one. So when you're talking about those two angles, just looking at their picture, looks like this is the part where they overlap. They kind of share this general area. And so we need to talk about that in some way about how we're going to get rid of that overlap so that we can just talk so that we can talk about those two angles. Also, when I'm looking at this angle, it's kind of made up of two parts. It's made up of angle 1 and 2. And then this one's kind of made up of angles 2 and 3 together. So we're going to have to talk about that kind of using that same idea of segment addition, only this time it's with angles. So I'm going to start right off the bat. I'm going to talk about this guy. Doesn't matter which one you really start with, that's just the one I picked. So EBA, this angle right here, is made up of angles 2 and 3. And that's the angle addition postulate. I'm taking two pieces, part plus a part, and I'm equaling the whole thing. Okay? I'm going to look at that for a moment, and I'm going to also talk about the other one as well. So DBC, the other angle. So I still want to talk about and kind of do the same thing. So the measure of angle DBC is made up of 1 and 2. Same reason, angle addition postulate. So now I've kind of talked about how this big angle is made up of two pieces, and this big angle is made up of two pieces. Okay? I'm going to substitute a little bit here. I need to somehow get these two guys to be equal to each other, and right now they're not. They both have an angle 2, so that's good, but where they don't match is with this 1 and 3. But since 1 and 3 are the same thing, I'm just going to substitute. So I'm just going to take this guy. Doesn't matter which one you would have picked. And I'm going to get rid of angle 1, and I'm going to put angle 3 in its place. And that is substitution. Once I replace it, since I know 1 is equal to 3, I just took out the 1 and put in a 3 instead. Now I've got 2 and 3, and I've got another 2 and 3. And so since those two guys are equal, then that means these two have to be equal. And your reason can either be substitution or transitive. So that's the beginning of an angle proof. Uses some part plus part equals whole. Same thing you were doing with segments. I will reiterate that these are tough. They're not easy to do, but you need to kind of keep plugging away at them. You know what the first step is going to be. It's always your given, and you know what the last step is going to be, and you just have to try and get yourself there and in between. So let's do one more for today. So this one is saying that I know that it's 1 and 2 are 90. So I'm going to put that there just so I don't forget. And I know that 2 and 3 are complementary. So if I were to add those two together, they're also going to equal 90. And we're going to have to say that. So first we're going to say that 90 degrees is 1 and 2. And then I'm going to say 3 and 2 are comp. And that's all your given stuff. So no big secret there. This stuff, since they are complementary, I'm going to be able to say that I could add them up then and equal 90. And that's definition of complementary. If I asked you what it meant to be complementary, you would tell me that means they equal 90. So I'm saying that as a statement. Since I have this as an equation, I kind of want to make another equation so I can do some adding or subtracting, or so I can get them to be equal to each other. So anytime you have words, you kind of want to turn them into equations so that you can work with them. Since both of those guys are equal to 90, all of this equals 90, all of this equals 90, I can kind of cut out the middle or cut out the overlap and set them equal to each other. And you can either do substitution or transitive on that one. I'm going to do transitive. So looking at my final equation, I know I'm supposed to get to 3 equaling 1. Well, that doesn't look too tough. There's my 1. There's my 3. I just have to get rid of the 2. So if I subtracted that from both sides, I would be left with 1 and 3. I will say it one more time. Proofs are hard. They are difficult to do. You know where the beginning is. It's all you're given. You know where the end is. That's your proof. And you're trying to make it work from start to finish. It might even help if you off to the side kind of say some words. If I know 1 and 2 are 90, and I know these two are complementary, I know that they equal 90 as well. So you kind of want to talk yourself through it and then figure out a way to put it down in words. Okay? And stick to that theorem card. All your reasons have to come off of it, so make sure that you're using that all the time.